Today, we begin our third day of our pre-cal review. We're going to look at the natural log functions and exponential functions. Okay, so the letter E scares everyone, right? You look at it and go, no. E is fine. How many of you are afraid of pi? No, you're like, pi is pi. E is like a pi. It's just a number. Okay, so don't be frightened of it. You treat it like you would treat a pi or a number. But let's look at the graphs. If I give you y equals e to the x, I need you to know what that looks like. What does that look like? Remember? Right? It goes through its pivot point. 0, 1 is the pivot point. That's what I like to call it. Or when you have an e to the x, you always start at 0, 1. If you need to move it right or left, you pick this point and you move it right or left, up or down. And then you just draw in what it looks like. What does it look like? It always looks like that, right? Now, if this x gets bigger and bigger, it might be tighter. You know, it could end up being taller or a little bit shorter, but that's what it looks like, always. And then we have an asymptote right there, right? So if I were to move this left, right, or up or down, I would move that one dot where it needed to be by my transformation rules. And then I just draw a curve in that looks just like that. It's not scary and difficult if you know what it is. The asymptote is y equals 0, right? Along this, it's always underneath the dot. The asymptote never crosses the curve, right? If I were to flip this upside down, it would be down here. The asymptote would not be in the way and cross the curve. What does a log look like? This could be ln or log, right? So we say y equals ln x or log x. Either one look the same. Their pivot point is 1, 0. And a log always looks like that. And the asymptote is at x equals 0, right? Now, whoops. For me as a kid, my big problem with this would be remembering which one's 0, 1 and which one's 1, 0. But I got a way you can cheat with your eyes on that. Log, right? ln or log. What numbers do you see in the word log? What numbers do those look like? 1, 0. So a log starts at 1, 0. And an exponential is the inverse of a log. And the inverse means we switch x and y. So this one is 0, 1. If you could keep that straight, they're not hard, right? So remember a log, LO, 1, 0, you'll never forget where it starts again. Logarithms grow very slowly. Exponentials grow very quickly, right? You know, germs spread. If I started a rumor today, if I started a really big rumor that our class was going to meet at Starbucks every day and we got free coffee, if I start that rumor right now, is that going to grow and get tweeted out fast or slow? Would it be an exponential or a log graph? Be an exponential, right? If I spread a rumor like that, the people will be lined up at the counselor's office to get in here, right? Rumors spread fast. I could start a good one. Or if we put in that, I have an ice cream softie machine in here, get that going, everybody be in, right? So remember, exponentials, we grow fast. Logarithms grow slow. They're going to keep going up. This will keep continuing to get bigger. It will grow. It's just very slowly. These are inverses of each other. Okay. We need to know that. This has to be engraved in the back of your eyelids. So when you close your eyes, you could see it, right? All right, let's review our properties of exponents. I want to make sure you get this. When we multiply becomes addition, right? And it works with variables and it works with numbers. We've got to know this so we can work with big numbers and not have to multiply 3 squared times 3 to the 4th and actually do that. When we divide, it becomes subtraction. We need to know this because when we expand and condense our logs, they go back and forth, don't they? We got to know these rules. Y'all know that a negative exponent in no way means a negative number, correct? It means flip it over. If I were to come over there and give you a negative sign, that would mean you'd have to stand on your head instead of your feet, right? It just turns us upside down. If they came and gave me a negative sign for this room, it would mean I need to put my room down on the 1st floor. Upside down, doesn't change the sign, flips you over. Okay, anything to the 0 power is 1 except for 0. We can't have 0 to the 0 power. Why does that work? Well, let's think about it. If I gave you a to the 9th over a to the 9th, what is 9 minus 9? 0. Well, what is anything divided by itself? 1. See? You see how that works? Okay. If we raise to a power and we've got things multiplied in here, variables multiplied, then each variable gets that exponent. Right here, when we raise to a power, we multiply. So we kind of have multiplication becomes addition with our powers, division becomes subtraction, raising to a power becomes multiplication. You've got to know those. We have to know these rules. Also, if I have a fraction raised to a power, then both the top and the bottom get that power. Like in our example over here, 2 over x cubed is 2 cubed over x cubed. The absolute value of a squared is the same thing as the absolute value of a outside squared. You kind of already know that. You intuitively do that one. Okay, so there's your review of rules. Now we'll practice. That's all there is. We got to do a little bit of practice and then you will be free for the day. All right, so let's do these together. What is 2 squared times 2 to the negative 3? What's my rule? Let's write down the rule. So it'd be 2 to the 2 plus negative 3. In your notes, write down what you're doing. Otherwise, you may look back later and say, how did I get that? So show yourself what you did. So that's really what? 2 to the negative 1. And what is 2 to the negative 1? 1 over 2, right? No big deal. Okay, this is raising to a power. What's the rule? We multiply, so write that down. Do I need to change 3 to the 6th to a number? I don't care. The rule of thumb for my mind is if it's a small number that you should know with your eye, do it. If you need a calculator, leave it like this. Like if it were 3 cubed, I'd expect you to write 27. But 3 to the 6th, maybe you don't have that one memorized yet, and you can't have a calculator. You're not going to have a calculator on this test, so we want to leave things to look correctly. Okay, 1/3 to the negative 2. Can I get rid of that negative 2 right away? I don't like it. So I'm going to say flip. So that's really 3 over 1 squared. I can get rid of the negative, right? And that is 9 over 1, which equals 9. Not bad, right? What about this fella? 2 and 3 are not the same number. So what do I have to do with that? Well, if you look back to our rules on the first page, since the exponents match, can I pull the exponent out? Yes. Right? Which equals 6 to the 1/2, which is the same thing as the square root of 6. So we better make a note so that you know that these have to match. So let's make a note. If exponents are the same, you can pull them out. We need to make sure that you're very clear and intentional with your thoughts when you think about those exponents. This only works if the exponents are the same. If they were different, I might be stuck. And remember, 1/2 power means square root. There are times when we do problems where it's easier to work with exponents, and there's times when we do problems where it's easier to work with a radical. So you need to be able to go back and forth so you can solve problems in the easiest possible way, right? None of us want to do it the hard way. Never mind that. Okay. Do you remember how to solve equations that have exponents? We'll try to get bases the same here. Can 27 and 9 both be written as a number to a power? Yes. 27 is really 3 cubed, correct? 9 is 3 squared. So this is really 3 to the 3x equals 3 squared. Now, if my bases are the same and I have an equal sign, would you agree that the exponents would have to be the same? For this to be true? They would. So now I could say 3x equals 2, x equals 2 thirds. Not bad, right? Can you make 3 and 9 the same base? Yes. But I don't want a 1/3. I want the 3 up top. So what can I call, how can I get the 3 to move up? Yes, I need a negative sign. A negative sign moves you to the other place, right? So this is really 3 to the -1. And 9 is 3 squared. So here, this is really 3 to the -x equals 3 squared. Bases are the same. There's an equal sign. So -x equals 2. Therefore, -2 equals x, right? It's the 2 that's negative, or x equals -2. I don't know why I wrote it that way. Okay, what about this? How do we handle this issue? Who loves that fraction? I don't want a fraction. Can you get rid of a fraction? What could you multiply 2/3 by to make it turn into a 1? What do you multiply something by to turn it into a 1? You multiply by its reciprocal, right? So if that's 2/3, I'm going to write 3/2 out here. And if I do it to one side, I had better do it to the other side. So 3/2 times 2/3 is 1. So I have x equals 9 to the 3/2. Is that true so far? Now I got to fix that. I can't leave that. What does 2/3 mean? It means the square root of 9 cubed. What is the square root of 9? 3 cubed. X equals 27. So anytime you need to get rid of a fraction exponent, We just multiply by the reciprocal and poof, like magic, it's gone. Let me ask you this. Is it legal in math to do anything you want to an equation as long as you do it to both sides? It is. So if I want to get rid of that, I'm getting rid of it. All right. What do you think we're going to do with this one? What would be the common base for 25 and 125? 5. So I'm going to say 25 is 5 squared. Now, once you write that, don't forget parentheses. 125 is 5 cubed. If you forget parentheses here, you'll end up with 2x plus 1. And that's not 2x plus 1. It's 2x plus 2 because you have to distribute. So now that I've got the same bases, this exponent must equal that exponent. So 2x plus 2 equals 3. 2x equals 1. X equals 1/2. Right? Lastly, we have this fella. So if you look at number 3, and now we look at number 5, is that the same kind of problem? Yes, it is. So what power are you going to raise the left side to get rid of it? 3/4. So 3/4, 4/3. Now that is power free. Now 16 to the 3/4 really means what? The 4th root of 16 cubed. Now remember, I'm not giving you a calculator, so these have to be small numbers. Nothing scary. So what is the 4th root of 16? 2. But 2 is cubed. So what do we really have? Right? 2 cubed is 8. So then we'll subtract 3. X equals 5. Not bad, right? You got this. Everybody good? Not too bad. All right. So we use the natural base of E all the time in calculus. We love it. It's really not scary. And by the time we do a million, you won't be scared anymore. So how would you solve this equation? Remember, E squared is just a number. It's like having a 2. It's almost like having 3 squared over there. It's 2.7, blah, 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 right? So it's just a number. What would you do to get this X by itself? Well, what are we going to do though? We have 2 in the bottom. Multiply both sides by 2, right? So now I have X squared equals 2E squared. And now, of course, we want X alone. We're going to take the square root of both sides. Now, what's the square root of E squared? E? Do you know the square root of 2? No. So what do we write? Square root of 2. Now, is this finished? Or is there one small problem? Does it need anything? I just took the square root of both sides with an X. Yes, we need plus or minus. Matter of fact, I might write that in a different color to make it big. So, need plus or minus when you take square root of variable. If we just took the square root of 36, the answer would be 6. But when we square root a variable, we have to have the plus or minus because this is X squared. So whether I put a plus or a minus in there, I'm going to get the same answer, right? All right, let's. Hey, does E equal E? Yes. So what's true about these exponents? They're the same. So we bring that over, right? There we go. Any questions about these? You feel okay with the E's? They're not bad. E is nothing but a number. All right, so we looked at natural law, exponentials. So now let's just practice our logs and then we'll be done. So let's write down those rules we wrote down just a second ago. What goes with multiplication? What do I do with exponents when I'm multiplying? Add. What do I do with division? I subtract exponents, right? And then power multiply. I put arrows going both ways because right here it says to expand, right? So going to the right, we're expanding. And if we did an arrow to the left, we're condensing, right? So I'm going to kind of from up here and I'm going to, so I can read this. For condensing, addition becomes multiplication, subtraction becomes division. So condensing, we read these to the left. Expanding, we read our little words to the right. I like to make everything easy, right? I don't want it to be hard. Okay, so would you agree, right, that this is multiply because there's nothing there? So you told me multiplication becomes addition. So it's going to be ln2 plus lnx plus ln y cubed. Right? We just turn multiplication into addition. Now a 3 is a power and a power means to multiply. So I have to bring the 3 out front. And I'm done. Now that's not too bad, is it? All right, what about this guy? Well, this is multiplication right there, and that's division. Multiplication becomes add, division becomes subtraction. So I'm going to say ln x plus ln square root of y, and I'll fix that square root in a minute, minus ln z. Now, we don't leave square roots in logs because a square root is really a power, and powers move to the front because we multiply. So I'm going to write out every step and you'll see it, and then you'll be able to do it in one quick step. But in our notes, we don't want one quick step, right? So your notes are to you for later. So that's ln x plus ln y to the 1/2 minus ln z. We need to always see roots as powers, fraction powers. A square root is a 1/2. Cube root is the 1/3, right? And now we know that this needs to be in the front. Now I know that you could go straight from here to this third step now that you've seen it, but we'd like all 3 of those in our notes so we don't get messed up later. Are those okay coming back to you? You looked at them in Algebra 2 and then in pre-cal during a year when you weren't paying attention. So now it's like, whoa, I know. You did this in spring of Algebra 2 when you were like, what? Right? Okay, now we're going to go backwards. So we're going to read our arrows to the left. So what does subtraction become? Division. And what does this become? Multiplication way out front becomes a power. So let's write this down. ln. So I'm going to have 3r to the 4th, right? That's this part. I'm going to do these all in different colors. Over, now that of course goes here. Now that says plus. So that's going to go up there. Why isn't that T in the bottom? In order for that T to be in the bottom, there would have to be parentheses around what I'm subtracting, right? I'm not subtracting that, I'm multiplying it. Now, 3 is a small number, so I would expect you to finish this. If this were too big to take to the fourth, we would just leave it, but it's not. So ln, what is 3 to the fourth? 81. We really want it cleaned up. When we're condensing, we're trying to get it as tight and squished together as we can, no extra stuff. So this is nice and small. Now, what about this one? What are we going to do here? Well, ln, and notice when you expand, every term gets an ln or an log. When we condense, you're only going to have one ln or one log. You won't have this written more than one time. What's this going to look like? Well, this is 3 minus, now this time we're subtracting the whole thing. So this is really what? This here becomes what? ln of 5x, because it's plus. So there we go, and we're done. Everybody comfortable with these? All right, the last thing. There are a few other properties that we need to know. Let's see if you remember them. When you see things that look like this, I need you to know what the answer is without blinking. So let's make sure you know what it's asking. What is this asking? What does ln1 mean? Well, let's look at it. ln1, ln means there's a little e there. We don't write it, it's understood. What this question is asking you is e to what power equals 1. So you're asking yourself, e to what power equals 1? Well, e to what power equals 1? What power do we raise stuff to get a 1? 0. What does this one mean? Remember, if you have e to the ln x, right? ln e is 1. So this and this go, and that's going to be your answer. Whether it's an x or a 5 or whatever I throw up there, when you see e raised to an ln, that x is the answer, or that the argument is the answer. Y'all know that this number, this thing right there, those are called the argument. So that way we have a word to describe them. It's called the argument. So what would be the answer to this one? ln e, what's its numerical value? Well, this is really ln, there's a little e. We're saying this little e raised to what power gives you e? 1. What about this one? Let me add another one. What's the answer to this? 7. What's the answer to this? 42. I want to have enough of those in your notes so you get the idea. When you see ln e, the answer is whatever the exponent is. ln e becomes 1. That's going to be a technique you're going to use over and over again in calculus. Things might look scary, and you're going to get a bunch of ln e's. And what do ln e's turn into? 1. So then it's not scary anymore, right? Okay, what about this one? What's the answer? 3. What's the answer to this one? Okay, that doesn't change. And what's the answer to this part? 5x. That's all I can do with that. I don't know what 3 plus 5x is. It doesn't do anything. And lastly, this guy right here. What would you do first with this? You want ln x by itself. So what do? Divide by 3. So now I have ln x equals 4. How do I get 4? How do I get the x out? Remember, what is the base with ln? E. Do you remember how to solve these when there's an equal sign? You draw you swoop, right? You go, whoosh, So e to the fourth equals x. Oh, I have x by itself. Now I'm done. I don't care what e to the fourth is. No one asked me to finish that. I could type that into a calculator and get it. Don't forget to swoop when you have an ln or a log and a number on the other side. Right? What if I had this one? Well, no, I don't want to do another one. So we'll just stop with that. Does that make sense? All righty.